Hello, I'm Jeremy and I'm a product specialist at Abstract. In this video, we're going to look at how to optimize scan data in InstaLOD Studio using InstaLOD's remesher. Today, we'll be looking at two different examples where we'll start with source data that contains millions of polygons, then easily optimize them for real-time scenarios. While it's not required to watch this video, you can learn more about remeshing in InstaLOD with our Getting Started with Remeshing video. There's a lot of great things to cover, so let's dive in. All right, so here we are in InstaLOD Studio. Let's first start off by creating a new profile, and I'm going to choose Remesh as our starting mesh operation, and we'll go ahead and create the profile. So now I'm just going to go ahead and off screen and grab a mesh that we're going to use. So let's go ahead and use this one. I'm just going to drag and drop it into the viewport into InstaLOD Studio to import it. So here you can see we have this really high res scan of Nefertiti. And so as you can see here, this mesh is 2 million polygons. It's extremely dense. If I go ahead and click on it and view the wireframe, you can see that there's a lot of topology here, a lot of detail in the face. You can see on the top here, every single pore is modeled out into the geometry. All the nooks and crannies and crevices here are in that topology. You can also see, if I go ahead and enable the UV viewer here, we don't have any UVs and we don't have any materials for this particular scan as well. So what I'd like to do is a few things. I'd like to lower down this polygon count and also like to generate some UVs and textures as well. And that's exactly what we can do with the remesher. I really like to get this mesh into a real-time ready scenario, whether it's in a game or, it's viewed on mobile or on the web. So we can see on the right here that we have my remesh settings, and I'm going to leave everything here by default. That includes the fuzzy face count target, which we have set to normal. That's how many polygons InstaLOD's going to use when it creates the reconstructed mesh. And then we have the surface construction resolution set to normal as well, and that's basically the resolution of the reconstruction. So the higher this resolution, the more details InstaLOD's going to model out into the geometry when it creates the new mesh. The lower that resolution is, the more simplistic the geometry is going to be, and instead, InstaLOD's going to bake all this high frequency detail into the textures or into the normal map for that reconstruction. So let's just go ahead and leave everything by default and hit start to let the remesher do its thing. So again, it's going to create a brand new mesh from scratch. It's going to unwrap the UVs of that reconstructed mesh, and then it's going to bake and transfer all the texture information onto that new mesh, including transferring all the high frequency details into the normal map. And as you can see, just in a matter of seconds here, we are already done. This is the newly reconstructed mesh here of our scan data. And we've gone from 2 million polygons down to just 5,500. And it did a beautiful result here very quickly. And I can show you that wireframe. And as you can see here, it's much more simplistic as the base form, as the base silhouette and features of the geometry. But instead, you can see it's modeled over all these pieces here. All the additional detail, like these pores, has been put into the textures, into the normal map in this case, of the model. You can see it's done some really nice work here where it's kept some nice edge flow around the eyes and the ears as well. It's really nicely done. And as you can see, we've gotten this real-time ready version of the model in just a matter of seconds with really just a click of a button. So let's go ahead and take a look at those UVs. I'll go ahead and bring up the UV viewer here. And as you can see, InstaLOD has created these nice, large, space-efficient shells here. Really big shells. In fact, mainly, if I enable the textures here, and we look at the normal map, you can actually see that most of the face is in one shell, which is really nice. These really big pieces here, and all those details, like those pores, have been put into the normal map instead. And it's a nice 2K texture here for the normal map as well. So as you can see, it's very easy to create a real-time ready version of this model. And so let's go ahead and create another version as well. Let's say that I want this model to be on a mobile platform or for AR, and we really need to crunch down all this detail, all of this geometry and get a very simplified version, very lightweight version of this model. What I can do is I'm just going to change the surface construction resolution from normal to lowest and go ahead and rerun the operation. I'm just going to tell it to run it on the unmodified version of the mesh, which is the initial version, the high poly, 2 million polygon version, and go ahead and rerun this reconstruction. So again, InstaLOD's going to create a new version of the model, unwrap UVs, and bake the textures. And as you can see very quickly, we're now down just about 2.7 thousand polygons, and we have a beautiful result here in just a matter of seconds. Again, take a look at the topology here. You can see that we've even modeled over more of the details. Again, because we have the resolution set to low, it's going to go ahead and create a more simplistic base shape even from before. You can see the ear as well. It's done a fantastic job of preserving those details. Even these intricate lines here, you can see were baked into the normal map for the ear. It looks really nice. So with just changing the resolution, you can see we can get some really nice results here. This would be great for mobile. All right, so let's go ahead and take a look at another example. All right, so here you can see that I've loaded in another scan of another statue. And again, we're dealing with a million polygons here in this case. So if I go ahead and click on this to reveal the wireframe, again, lots of dense amount of triangles, polygons here. Way too many polygons for a real-time ready asset. But as you can see, it's quite an intricate piece here. We've got, parts touching, and we've got gaps here, things like that. A lot going on here, but there are actually quite a few problems with this particular model. The first thing, aside from the polygon count that I want to draw your attention to, is down here at the bottom. So this asset was created using photogrammetry, where someone took a whole bunch of photos from different viewpoints of the model, and then the mesh was then reconstructed from that photo data. And as you can see down here, during that reconstruction process from photogrammetry, it's also captured some information of the floor and of this dirt. And so this doesn't look very good. If I want to bring this into a game or present this, I want to be able to remove and clean up this model a little bit. Another thing you're going to notice from this model is if I look at the bottom, you can see we have a large hole at the bottom here, and there aren't any back faces. You can see if I enable back faces here, this is the geometry, but we don't have any of those back faces, and so this can be a problem for some remeshers. If this mesh isn't watertight, what remeshers commonly will do is model additional faces on the other side of these polygons, giving you double the amount of topology, which we don't want. Luckily for InstaLOD, that's not going to be a problem. However, another problem with this mesh has to do with the textures. You can see we have lots of, finely detailed textures here of the stone material and stuff like this. But if I go ahead and bring up the UV viewer here, what we're going to see is that the way that the UVs were created for this photogrammetry asset is that they were not spaced out very well or created very efficiently. You can see that we have a bunch of these small UV shells here with lots of gaps. And in order to get all of this information here on the model, they had to use an 8K texture. As you can see, a larger texture resolution is needed because we have all these different UV shells, all these small pieces packed together this way, and it's not very efficient. So there's a lot of problems with this, and we're going to be able to fix all of them using InstaLOD and the remesher. So what I'm going to do, I've just loaded up a fresh profile here using the remesher with its default settings. And the only thing I'm going to change here for the settings has to do with this hole here on the bottom. I mentioned that remeshers, naturally, they want to cover the other side of these back faces. So to prevent that from happening, what we can do is just enable ignore back faces here. And so what that means is that InstaLOD is going to understand that if we have a border here, and you can see it's marked by this red line, it's not going to model on the other side of this mesh. So without any other changes, I'm just going to go ahead and hit start and let the remesher run. It's going to create a newly reconstructed mesh here. It's going to unwrap those UVs much more efficiently, and it's going to bake and transfer again all the texture information, including the stone texture, and also, transfer all that high poly detail into the normal map of this mesh. So there you go. Very quickly, within a matter of seconds, we now have a 19,000 polygon version of this model instead of the 1 million polygon version. And as you can see here, it's only modeled out the details that it needs. Things like the eyes, the mouth, all that additional information has been baked into the normal map. You can see here on this part here. It's done a fantastic job. You can see even that these details here have been preserved with a much more simplistic mesh. And take a look at the side here. Really nice connections. You can see we haven't filled in any of these holes. It's looking very nice. So very easily, as you can see, oh, of course, if we look at the bottom, right? No back faces, right? It understood that it didn't need to model any extra faces needed, which is great. Now let's go take a look at the UVs. I'll just bring up the UV viewer. And there you go. We can see that we have these really nice, large UV shells for this model. And if I show you the textures, I'll go ahead and bring up that normal map again. All that detail is baked into the object space normal map. You can, of course, create a tangent space normal map if you need it. But as you can see, our textures are only 2K here. We really didn't need an 8K texture resolution for this model. 2K was plenty. So really nice job. So let's tackle some of the problems. Now, we have this real-time ready model, but as I mentioned, we've got this extra data here at the bottom. How can we remove it? Well, what I'm going to do is I'm going to go back to the unmodified mesh here, going back in my timeline. And I'll just go ahead and delete my timeline history. And what I'm going to do is I'll disable ignore back faces here, but I'm going to add a clipping plane. So if I add the clipping plane, you can see it adds this plane here, and I've got my gizmos here on the left. I'm just going to go ahead and click the translate gizmo here, and you can see that I can move this clipping plane. I can even rotate this if I want to, but I'm just going to position it right down here. And so what this clipping plane does is anything behind the clipping plane is going to be automatically clipped or removed. So anything below this pink area is automatically going to be capped off here, and it's going to get rid of this extra data. And what it also does, because I could ignore back faces because of this, is it's also going to prevent InstaLOD from remeshing the inside of the model or those back faces as well. So it does two things for the price of one. So I think I've got a pretty good positioning here for that clipping plane. We could, of course, add multiple clipping planes if we wanted to, cap off the back or something like this, but I think that's fine. And again, let's go ahead and start the reconstruction. So this time it's going to do everything it did before, but it's going to remove that additional data underneath our clipping plane. So I'll go ahead and just remove the plane here. But as you can see, we now have a really nice smooth cutoff here at the bottom. InstaLOD again reconstructed the model, but again, it didn't create any additional back faces, and this looks much cleaner. So the last problem that I want to bring up here with this scan data has to do with the textures. And in this case, I mentioned this was captured using photogrammetry. So let me go ahead and go back to the unmodified version again. And photogrammetry is a fantastic way to capture lots of detail and turn it into a 3D model. And it includes all the textures and all of the, high poly, high frequency data. However, even though you're capturing all that really nice data, you're also capturing some of the data that you don't want, including things like these shadows. This was the lighting scenario when this asset was captured. And so if I just go to my viewport settings here and I just go and change the render mode to unlit, what this does is show us the model with just the base color with no additional lighting from InstaLOD's viewport. And as you can see, we have these shadows in the crevices of this model. And so if I were to put this model in a different lighting scenario, the shadows aren't going to make sense because they're just baked into the asset. So what we can do is we can actually delight this asset using our remesher here in InstaLOD at the same time that we're doing a reconstruction and optimizing it. It's a great thing to do as you're processing assets in InstaLOD. So we're going to remove all the additional highlights and shadows. So let's go back to material mode here, PBR mode, and let's go ahead and show you how I can do delighting. So I'm going to go over to the texture output settings. In fact, before I do that, let me just quickly add that clipping plane again so we can just remove any of that unnecessary data. That looks pretty good. Go over to my texture output settings here, and here's where we can do things like set the texture resolution. So remember, we created a 2K texture map for the object space normal map and any additional textures that were on the model originally. But we could also adjust the resolution here. So I could set it to something like 1K if I really wanted to lower down the texture resolution and get this very quickly running on mobile. But 2K I think is also fine in this case. And so what we can also do aside from setting the texture resolution and baking some additional maps is we can also turn on our delight settings here. So I'll go ahead and just enable this, and that's everything we need to do to remove those additional highlights and shadows. So before running this operation, I'm actually going to duplicate it. I'm going to go to the Mesh Operations panel here, click Duplicate, and I'm going to call this delit. And then for the other operation, I'm just going to remove delighting. And so what this means is InstaLOD's going to run the remesh operation twice, once with delighting disabled and once with it enabled, so we can easily swap back between the two to see the differences. So let's go ahead and hit start. And so InstaLOD's actually going to run this reconstruction process twice, and it's going to do it very quickly here on my machine. It's going to model out only the topology and geometry necessary, again, unwrap those nice, efficient UV shells, and bake and transfer maps, while also doing the delighting process. And so there you go. Let me go ahead and hide the clipping plane again. Another beautiful reconstruction here from InstaLOD and the remesher. And so I'm going to go ahead and just zoom into this area. Again, you can see there aren't any shadows here because the delighting process had happened. But if I just go ahead and hover over these two tabs to show the two versions, you can see the huge difference that delighting has on this model. And again, I'll go into unlit mode here. And you can see this massive difference that delighting has. So as you can see, it's really easy to be able to optimize really heavy scan data using InstaLOD's remesher, clean up any additional information that you might have at the bottom, and also improve the base color map so that you can bring this model into many different lighting scenarios and get accurate results. Thanks very much for watching this video on optimizing scan data with InstaLOD's remesher, and we'll see you in the next video. If you enjoyed this video, drop us a comment below, and don't forget to subscribe. For the latest news about InstaLOD, please visit our website and follow us on Twitter. You can find all the links in the video description below. Thanks for tuning in, and we'll see you in the next one.